So now I'm going to be going over what a jump discontinuity looks like and how to find the limit of a jump discontinuity. So this is what a jump discontinuity looks like on a graph. It kind of looks like the graph just stopped here and then jumped up, right? Thus the name jump discontinuity. So I'm going to explain how you could find the limit for a jump discontinuity. You can't find the limit as a whole, because there's a jump here. I'm going to explain that in more detail by finding the limits from the left and the right. But with that being said, you can find the individual limits from the left and the right for this graph. So let's find the limit from the left first. Let's find the limit from the left first. So the limit as x approaches 4 from the left for the function f of x, and this function is named f of x. And that would be equal to, so let's see, we're approaching from the left, we're approaching 4 from the left side of the graph, and as you can see, we get closer and closer to 3, so therefore it would be equal to 3, all right? Now let's find it from the right. So the limit as x approaches 4 from the right for the function f of x, so from the right, we approach 4, and we see that it actually equals 8. It's not going to equal 3 this time, because you're approaching 4 from the right this time, which is different, because from the right, it actually stops at 8. It doesn't continue on and stop at 3. So the limit as x approaches 4 from the right for f of x would actually be 8. And now, when you try to find the limit as a whole, the limits from the left and the right have to be equal to each other. In this case, 3 does not equal 8. So therefore, we can say that the limit as x approaches 4 for the function f of x does not exist, solely because 3 does not equal 8. Now we're going to be going over continuity for this type of graph. Continuity for this graph does not exist, but on all of your tests and quizzes, you're going to need to prove why it doesn't exist. You can't just look at a graph and be like, oh, it doesn't exist. You actually have to prove it. So let's start off by looking at the first step. The first step is trying to see if f of 4 exists. Now, in this case, f of 4 actually does exist. So in this case, f of 4 actually does exist, because this circle right here is filled in. So that means that this point is actually included in the domain, which means that f of 4 would actually indeed exist. And because the point is filled out here and not here, f of 4 would actually be 8 instead of 3. So f of 4 equals 8. Now we look at the second step. The second step, obviously find the limits from both sides. We already said that the limit as a whole does not exist because the limits from the left and the right are different. So I'm just going to write that down really quickly. 4 from the left equals 3. The limit as x approaches 4 from the right equals 8. All right. And now we're going to look at the third step. All right. The third step is looking to see if the first step, the answer to the first step, equals the answer to the second step. In this case, if 8 equals the limit as a whole. We already said that the limit as a whole, that's a very bad one. We already established that the limit as a whole does not exist, as 3 definitely does not equal 8. So that means that f of 4 does not equal the limit as x approaches 4 for the function f of x. And so these are the steps you have to take in order to prove that a jump discontinuity is not continuous. Okay, so now I'm going to be showing you how to find the limit of a function by just looking at a table. I want you to pretend for a quick moment that this graph does not exist and you're only given this table. This table will help you determine whether the limit of a function exists, or if it does not exist as a whole. So 3.9, 3.994, 4.01, 4.1. What does that signify? Well, that pretty much lets you know on the table that these values have to be very close to the value of the limit that you're trying to find. For 3.99, I'll put 2.97, and then 4 actually equals 8. Now, in the last one, where Sahil was talking about a whole discontinuity, we said that the value of the limit that the x value of the limit that we're trying to find actually does not exist. In this case, it exists because this point right here is circled in. So that's very important to keep in mind. And then we're going to continue from 4.01. So now we're going to continue from here. We're not going to continue from this part of the graph. We're going to continue from this part of the graph. So for 4.01, we'll say it's like about 7.98, and then for 4.1 we'll put 7.67. Okay, so very clearly you can tell that the limit as a whole does not exist. Like, you literally jump from 2.97 all the way to 8. So that alone should tell you that the limit as a whole should not exist.